this challenge, and I think it's relevant to the theme of this conference as to their perspectives and where they come from on that. So you've had enough from me. I will stay around. We can chat about the Institute if anyone wishes to do so, but I think the main thing I'd like to hear from is our faculty who look at this, who are really focused on particular aspects of that. So Georgina, do you wish to?
To be here, and thanks for everyone who's attending. It's an honor and a privilege to have the opportunity to talk to you. So I am Georgina Bingham. I'm a Research Associate Professor in the Department of Entomology. And my research program and teaching covers quite broad areas. So we cover water and food security and nutrition, and we also cover areas of One Health, so public health, animal health, and how they interact with environmental health. As it looks as a bigger system. And so these are obviously very broad areas, but being in the Department of Entomology, we are looking at it through the entomological lens. So we're looking at the interactions with insects and arthropods. So I'm sure we've all met ticks out there, so ticks are something that I work on, not my favorite. I'm a real tick magnet, so. But yeah, so we work on ticks and various other insects, and I'm gonna introduce them to you. Here. And the funny thing is, coming here was like coming home, because if you were to trade corn with wheat, you can see the picture up here, I would be basically home. So I feel very at home here and very at home in the rural communities. And so I consider myself a daughter, a sister, a mother, along with being a researcher and a teacher, which is a great privilege, as I mentioned. So prior to working at the University of Nebraska, I was working for a humanitarian company based in Switzerland. And so this was a profit for purpose company. So everything that we did, everything that we designed was for the most vulnerable in society. And I had this incredible experience of being able to use my education to share with communities, to look at different problems like malaria. So I got to work on malaria mosquito nets, combating these malaria mosquitoes. I got to work with farming communities, combating this fly here. It's called the tsetse fly. It transmits a disease called sleeping sickness, and I'll come back to that. But so it causes terrible damage to livestock. You can see this pig here is infected with sleeping sickness, but it can also kill people too. So it's an extremely debilitating disease for humans and for the economics of the country. We also worked with something called live straw. I'm not sure if you've heard of it, but basically that filters all of the pathogens, parasites, bacteria out of the water. And it all comes back to water at the end of the day. I think it's the starting point. People say water is life, but if you have waterborne pathogens and you take that dirty water in and then you eat, but you have diarrheal disease, for example, that food isn't going to do you any good nutritionally. So it's something that I like to keep coming back to. And if there's anything that I would like you to take away from what I talk about is, in this polarized world, I would like us all to kind of look more towards the connectivity, kind of inclusivity, and look for the similarities rather than the differences. Because as I'm going to show you, there are a lot of similarities. So I got invited into these people's homes. I got to talk to them, talk in their communities, understand the problems from their perspectives, how these diseases and how these issues were affecting their family, their community, children's education. And I feel like as I've come here to Nebraska, there are a lot of similarities with the problems that people face, communities face. So kind of my key take-home message is that let's look for the similarities. We're all one big global community. So I've had the privilege of working with many different types of farmers in many different places, as I mentioned. And so working with the Maasai pastoralists, working here in Nebraska with the dairy and pasture cattle systems, working also we have a Indigenous Food Sovereignty high school course here. I'm not sure if you're aware of it. It is fantastic. I've been quite involved in it. This is the group. They set up a community garden, learn how to grow food, and actually look back into the different cultivars and varieties as they look back into the original Indigenous food supply. So I love bugs, and this is why. As we look here at this picture, I just absolutely love that diversity. Every single shape, size, pattern, color, it's just phenomenal to me. And then this picture here makes us realize that how important they are. So they are one of the most prolific organisms on this earth. And I don't think that's going to change. So 1 million species of insects have been described, and there are projections that there are several other millions that still haven't been found yet. But I'm going to focus on the problem. So there are many amazing insects that are beneficial to us. This is one of the problems that we have here in the Great Plains. This is the Culex mosquito that transmits West Nile, and we have a lot of West Nile here in the Great Plains. This is the stable fly. This is a blood-feeding fly that feeds on livestock, not just livestock. When you have this many numbers, they'll come across and they'll feed on dog ears. They'll feed on you. If you ever get bitten around the ankles, that's a stable fly. But you can see here, this calf probably won't survive. It is basically being exsanguinated by these huge numbers of blood-feeding flies. So this is one of the flies that I work on that currently is endemic and a big issue here. We also have the various tick species that cause alpha-gal. Has anyone heard of alpha-gal here? It's an immunological response, which means that the person becomes allergic to meat and animal products. So for me, that'd be a big problem because I wouldn't be able to eat my steaks. It's also a big problem for the beef industry here in Nebraska. So these are already present here and endemic to this region. So we talk about climate change, and I feel like climate is a bit of a dirty word these days. It's become polarized, like so many things, and used politically. When I talk about it teaching my classes, I talk about prevalent weather, and talk about weather and long-term effects of weather. And so I think if we could move away from the word climate, perhaps we could actually start looking at it in a more practical sense. But here in the Great Plains region, we have 3 new bugs that have come in, whether it's climate change, whether it's change in prevalent weather. These insects now are able to, and arthropods are able to live here and do well. So this is the black-legged tick that transmits Lyme disease. So when we go hiking, more and more we're going to have to worry about Lyme disease. This is the tiger mosquito transmitting dengue fever, yellow fever, and Zika, potentially, if those diseases ever come back to this region. So we have the vector present. And those are now very present here. I have plenty of them in my backyard and garden. This is the kissing bug. So when I was talking about sleeping sickness, I said I'd come back to that. American sleeping sickness, or Chagas, is transmitted by this bug here. Over the last 2 years, we've had 2 species of kissing bug found for the first time in Nebraska. And so, again, this is another issue that we're going to have, our communities and our families and everybody, researchers are going to have to face and deal with. And so yeah, so similar, different, yeah. Last thing I just want to talk about quickly is, so I've worked on pests for growing crops, I worked on livestock pests, and how that all integrates within the system. The last step in the chain is food storage. This is Zambia. This is 1 year of storage of maize, corn, and this damage here that you can see is due to the insect pests. And when I walked over to this stack and I touched it, it just crumbled. There was nothing left. So after 1 year of storage, all that food was gone. And so we worked on a few different solutions. And so food storage isn't just a problem for Africa and developing countries. It's also a problem here. Something that we also need to more and more face more and more, especially as we look at those projections of population going up and up and up. And so this here is the corn storage in Zambia, and using some bags that we developed within the company that I used to work for that protects against the insects. I can talk to anyone more about that if they're interested. And then this is my son here in Lincoln, Nebraska. So I just kind of wanted to leave you with that image. We're not so far away from each other. Everything is kind of similar but different, and we all face similar problems. And yeah, so we need to work together as a kind of global family. We need to be conscious. I think tackling inequities, not just inequalities, inequities is highly important as we look at poverty, education particularly, and our behavior. We need to hold ourselves and our leaders accountable to make sure that they do what they say they're going to do. And the thing that around the dinner table, I talk to my kids about all the time is that it's not just about what someone else can do. It's not about what everybody else is going to do to solve these problems. I can do something, I can do something. So thank you so much for your time, I really appreciate it.
Thank you, Georgina. In fact, Kelly, we can hold off questions until we get through our 3 speakers.
Different ways that we detect drought impacts. Why would anyone want to detect drought impacts? Okay, back up a little. I work at the National Drought Mitigation Center. We actually were based here at UNL over in Hardin Hall in the School of Natural Resources. We are based here in Nebraska. We have a national mission. And before we were the National Drought Mitigation Center, we actually were the International Drought Information Center. So we have continued, about a third of our work since we were established in 1995 is international. So a great deal of what we do applies locally, nationally, and also internationally. We have lots of scholarly publications on how to plan for drought, but here is drought planning in an absolute nutshell. It's how does drought affect you, and what do you need to protect from drought, or who do you need to protect from drought? Then how do you know, how will you know when drought is emerging? What's your early warning system? It's slow moving. So it is considered a natural disaster, but it's slow moving and it doesn't have hard edges in time or in space. So it's a little hard to sometimes realize that you're in the thick of things until it's too late. You don't have as many good options. If you can detect it early, that gives you more good options. And that's where I come in, is how do we detect drought impacts before they get out of hand? We don't always know what to monitor, so we take advantage of information that's already out there. I'm gonna give you a quick overview of tools in the Drought Impacts Toolkit, and then I'm gonna go into depth on one of them. We have something called the Drought Impact Reporter. This is actually based on somebody reading news stories every day and entering information about drought impacts into this database that becomes a dashboard. We have a second media-based tool that doesn't require as much human intervention. It's just an automatic search and filter process that I update every week. Then we have social media too. And of course, people have said, oh, why don't you look on Twitter? And sometimes there is great information to be found on Twitter, like a farmer showing a picture of dust off the back of their tractor that literally will tell people who are trying to assess drought, oh, it's really bad in this corner of South Dakota right now. Sometimes new information emerges that way. Of course, social media is also kind of chaotic, as we know. The thing I'm going to talk to you most about today is called CMOR, Condition Monitoring Observer Reports, that help us see more drought. And this is a structured way to get information from the grassroots and filter it back up to state and national teams that are assessing where drought is. And this is also something that we are in conversations with our international partners about pioneering in doing a beta test version in certain African countries and things like that to see how applicable it is, and I'll tell you more about that. And then finally, there's something called the Drought Impacts Multi-Tool for people who like to turn on too many layers all at the same time, but it does let you make comparisons between all these different channels. So this is what the CMOR dashboard looks like. Dashboards are great for quick filtering, and you see some options over on the left. Personally, I'm a huge fan of timelines, time series data. So you also have kind of a track record showing when they've been, when reports have been submitted over time. This is just a year-to-date view. The colors on the map are, people are asked to describe what they're seeing on a 7-point dry to wet scale. So the blues are wetter and the browns and reds are drier. And they also have an option to upload photos. You can see we have a couple of people across the country that have really taken upon themselves to do this every week, which is ideal. That way we know what your place looks like in dry, wet, and normal times, because drought is all about the deviation from normal, from what you'd expect. You can't just send us a picture and say, boy, this looks like drought, and it's like, well, what does that look like normally? Please give us something to contrast that with. So this is, one other thing that we do is collect information about crop conditions on the same scale that the U.S. Department of Agriculture uses. I think it's from very poor to excellent. So these are just year-to-date reports that have ticked off one of those boxes. And this is recent conditions in Kansas. Drought is really bad there now. I don't know if you've been there lately, but it's very dusty and very windy in Kansas right now. So this is a little bit about the way it looks. I actually started my working life as a newspaper reporter, and then I came to work at the university, and I was as a communications person, and I thought, I'm just always dishing out information from experts. And yes, that is what universities do, but the rebel in me wanted to reverse the flow of information. How can we give people on the ground a voice in this process? And that's very literally, states have told us that is what the Seymour reports are doing. If people are sometimes in crisis, they call and say, it's terrible, and the state climatologist says, please file a report here and it will appear on the map. Don't rely on me to relay your message. Just put it on the map and it becomes part of a permanent public archive that way. And some states actually have opted to use it in different ways to have extension agents be the primary observers on behalf of everyone, which actually results in a very nice, even pattern over time, less crisis-driven and a little bit more credible, but different extension services have very different mandates and priorities. So we're still trying to figure out what the best system of local and regional partners is for getting Seymour reports rolled out. But it all ultimately filters into, it's one of the data sources consulted by the people who draw the lines on the US Drought Monitor map. And that map is actually responsible for billions of dollars in assistance, especially through the Livestock Forage Disaster Program. So it ultimately matters a lot, our ability to depict where drought is and how intense it is. It works on mobile. People always want to know that. And there's quite a bit of how-to information that's available. This is all built on an Esri platform. Originally with the Drought Impact Reporter, that first tool I showed you, we had a submit a report button, but it was hard-coded. And so there were some things we wished that we hadn't asked and that turned out not to be relevant and that confused people. So one of the benefits of using this off-the-shelf Esri technology, Survey 123 for the report forms, then it flows right into a geodatabase and you can make a dashboard out of that, is that we can really easily reconfigure the questions. So I think when we roll out something in countries in South Africa, first we'll say, or in the Southern Africa Development Community, I believe, we'll be working with those countries. First we'll say, okay, what impacts are important in your country? What do you want to ask people about? And it's really easy. You don't have to be a programmer to configure a survey that gathers that information and automatically appears on the map. So the technology is making a lot possible. In some ways, yeah, used correctly, it's quite a bit more structured, of course, than social media. There are things that people can check off and you can get structured input and a much more systematic way of gathering observations than what someone happens to be motivated to tweet on a certain day. Of course, it does rely on someone spending some portion of their lifetime to upload a report. It doesn't take long, but it can be surprisingly difficult to motivate people without the right network or group in place. And I think, yeah, we'll do questions later.
My lab is doing. So as a self-introduction, I'm a plant physiologist, so I study how plants work, how they respond to their environments, especially to their environment. So the things that my lab is interested in is the water and temperature responses. So we look at both the water quantity, so like things like drought, and also the water quality, which would get affected if you have high amounts of salts dissolved in the water. So that also impacts plants' growth and crop productivity and quality. The other thing that we study is temperature, especially high temperature. And so we do this mostly in cereals. So we work with wheat, rice, and maize and sorghum to some degree, but generally mostly wheat and rice. And today I'm going to give you some glimpses of of things, not exactly like just lay the context and then kind of go from there. So some of the things that we work on include looking at the developing rice grains. So we've developed technologies with people group at computer science to look at almost at the resolution of a single grain and how it responds to temperature, and we could do this for drought and so on. And that affects, the reason we want to study that is because if you were to take every grain from here and each one of them is very different and it would respond quite differently to the temperature, let's say high temperature. And that would make a difference on what ends up on the plate. So why temperatures? That's kind of what I'm going to emphasize. If you look at this global maps, so these are just small micro maps of temperature anomalies. So if starting from 1850, so about 140 years worth of temperature anomalies. So if you take the average temperature for any spot on the Earth, on the landmass, and you, for these 140 years, and you say that I'm going to color it blue if it's cooler than the average, and I'm going to color it red or orange depending on how hot it got away from the anomaly. So that the trend, as Kelly mentioned about time series, is showing that the things are kind of getting warmer. So what I study specifically, I study heat stress and how grains develop under higher temperature, but more recently I've studied not only just high temperature, but the diurnal difference in temperature. So it turns out when you look at some global maps, the night time, so this is kind of a global map for average daily maximum and average daily minimum. So what was very obvious is that even though temperatures have increased both during the daytime as well as the nighttime, but the spread of nighttime temperature and the intensity of nighttime temperature is more. So essentially, nights are getting warmer at a higher rate than daytime temperatures, and that spread is actually geographically more uniform compared to more patchy patterns that you would see for higher daytime temperatures. So how does this is globally, and this is what the temperature trends for day and night look for the US. So starting from 1910, the orange is your hot daily lows. So these are smoothed out graphs. It just shows that both the day and night temperature product, locally produced in Nebraska, and how its impact of drought and heat on the availability of proteins, as well as in rice. So what they're reporting is that the amount of, so even though you consume, let's say, a pound of rice in a week, the amount of digestible starch after cooking the rice decreases about 10-12% when you have a grain that structurally looks like this instead of this. So similar evidence was also found for the number of peptides that can be extracted from a cooked bean that has been exposed to hotter and drier environment. So this is kind of being done in collaboration with the drive-in breeder in Western Nebraska, and for the rice, we are collaborating with the International Rice Research Institute to look at both the quality, the nutritional quality of rice, as well as the glycemic index. We think that the rice has a very high glycemic index, which can add to the load on type 2 diabetes. Large part of the population is also pre-diabetic, but they consume a lot of rice. So having, what's the impact of a stress like this, like warmer nights or warmer day and nights on the nutrition and the health of people. And I think it can have a huge impact, primarily because the amount of calories that crop like rice or wheat or beans provides for humans. So
Thank you.